8216. A cool-off period prior to shutdown of a turbine engine is accomplished in order to A. Allow the turbine wheel to cool before the case contracts around it. B. Prevent vapor lock in the fuel control and/or fuel lines. C. Prevent seizure of the engine bearings. The correct answer is A. The cool-off period prior to shutting down a turbine engine is implemented to allow the turbine wheel to cool down before the engine case contracts around it. During engine operation, the turbine will becomes extremely hot due to the high temperatures generated by the combustion process. If the engine is shut down abruptly without a cool-off period, the sudden temperature change can cause the turbine wheel to warp or distort as the engine case contracts around it. This can lead to potential damage to the turbine and other engine components. 8217. What type igniter plug is used in the low-tension ignition system of an aircraft turbofan engine? A. Low-voltage, high-amperage glow plug. B. Self-ionizing or shunted-gap type plug. C. Recessed surface gap plug. The correct answer is B. In the low-tension ignition system of an aircraft turbofan engine, the type of igniter plug used is the self-ionizing or shunted-gap type plug. This type of igniter plug operates by creating a high-voltage spark across a small gap, which initiates the combustion process in the engine. The self-ionizing or shunted-gap type plug is designed to be self-sustaining once the initial spark is created. It uses a shunt resistor or capacitor to maintain the ionization and continuous discharge between the electrodes, ensuring reliable ignition of the fuel-air mixture in the combustion chamber. 8218. What is meant by a shrouded turbine? A. The turbine blades are so that their ends form a band or shroud. B. The turbine wheel is enclosed by a protective shroud to contain the blades in case of failure. C. The turbine wheel has a shroud or duct which provides cooling air to the turbine blades. The correct answer is A. In a shrouded turbine, the turbine blades are designed in such a way that their ends form a band or shroud. The shroud serves as a continuous ring around the outer edges of the turbine blades, enclosing the tips of the blades. The purpose of the shroud is to provide structural support to the turbine blades and reduce the leakage of gases across the blade tips. It helps to maintain the aerodynamic efficiency of the turbine by minimizing the flow losses caused by the leakage of high-pressure gases from the high-pressure side to the low-pressure side of the turbine. 8219. What term is used to describe a permanent and cumulative deformation of the turbine blades of a turbojet engine? A. Stretch. B. Distortion. C. Creep. The correct answer is C. Creep is the term used to describe a permanent and cumulative deformation of the turbine blades in a turbojet engine. It occurs over an extended period of time when the turbine blades are subjected to high temperatures and mechanical stress. During engine operation, the turbine blades are exposed to high temperatures caused by the combustion process. These high temperatures, combined with the centrifugal forces acting on the blades, can lead to a gradual deformation of the blade material, causing creep. 8220. What is the purpose of the dump valve used on aircraft gas turbine engines? A. The fuel is quickly cut off to the nozzles and the manifolds are drained, preventing fuel off as a result of residual engine heat. B. The valve controls compressor stall by dumping. C. Maintains minimum fuel pressure to the engine fuel control unit inlet and dumps excessive fuel back to the inlet of the engine-driven fuel pump. The correct answer is A. The dump valve used on aircraft gas turbine engines serves the purpose of quickly cutting off the fuel supply to the fuel nozzles and draining the fuel manifolds. This action prevents the fuel from igniting or vaporizing due to residual engine heat after engine shutdown. After the engine is shut down, there is still residual heat present in the engine, including in the combustion chamber and the fuel nozzles. If fuel were to remain in the nozzles and manifolds, it could vaporize and potentially ignite. leading to a hazardous situation.